Okay, so we just finished coming up with this explicit formula for arithmetic sequences, and we did one quick example where we came up with an explicit formula for a particular sequence that I came up with. What I want to do next is using that same, I'm going to go ahead and copy this. Using this same example, let's go ahead and let's see if we can come up with, shift this down a little bit. Let's see if we can come up with what is the, we'll go 27th term of this sequence. Okay. Well, if you were very inefficient, what you could do with this is you could go 3, 7, 11, 15, 19, and then notice we're adding 4 every time, so 23, 27, 31, 35, and so on and so forth. And you could list out all the terms all the way up to the 27th term. That would be one way of doing this problem. And you could get the right answer that way, but it's not very efficient because we just came up with the explicit formula. It's 4n minus 1. Well, in order to find the 27th term, I'm trying to find a sub 27, so all that means is I'm going to go to where n is, I'm going to plug in 27, and then I'm going to find my formula. So 4 times 27, that is, what do we got, 108 minus 1. If you were to list out all 27 terms, you would see that the 27th term is definitely 107 in this case, okay? So I wanted to add that on to the last example, and I'm just going to do one more quick example for you guys here. So we all have for you for now, and then we will continue talking about these some, and we'll actually get into something called series, which is an extension of sequences. We'll talk about that on Monday. So for our final example, and then I'm going to give you guys one to practice or to try over the weekend, and we'll see who has it on Monday. For our final example, though, let's go with this. Let's try 99, and then let's go 93, 87, 81, 75, ... Okay? Now we can see that this is an arithmetic sequence because notice here we subtract 6 every time. Okay? We're subtracting 6 every time. If it helps you, each time that you do this, you can write it this way. Okay, so 1, that's my first term, is 99. My common difference, now what a lot of people will do on this is they'll say that the common difference is 6. Common difference here is not positive 6, it's actually negative 6, because each time to get from one term to the next, we are subtracting 6. So if you think about that explicit formula that we came up with, here's what it looked like. A sub n equals a sub 1 plus n minus 1 times d. And I should also mention, don't worry guys, I'm not going to make you memorize any of these formulas. I will give you a sheet of paper when you take a quiz or test that has these formulas on them. Now I'm not going to tell you this is the formula, this is the explicit formula for an arithmetic series, but the formula will be on there, so as long as you can identify it, then you'll be good to go for using it on a quiz. But the reason why I'm saying that, once we have this formula, now we can just plug in this information and we can go from there. Okay, so our a sub 1 in this case is 99. Okay, and our common difference here is, notice I'm putting this inside of parentheses, negative 6. I'm putting this inside of parentheses because I need to distribute it to this n minus 1 to clean this up a little bit. So this is going to become 99. Negative 6 times n becomes minus 6n, and negative 6 times negative 1 becomes a positive 6. So when we're finished, 99 plus 6 is 105 minus 6n. So here's my explicit formula for this. Okay, and I'm finding that first because my next question here is, what is the 100th term of this sequence? Okay. Again, if you wanted to list out all 100 terms, it would take you a while, but you could do it. You are not going to have enough time to do that on a quiz or a test, which is why it's important to know how to use this formula. If I want to know the 100th term, let's go to this formula that we've come up with, and let's figure it out by plugging in 100 for n. Okay, so I'm plugging in 100 for n right here. This is just simple math. 105 minus 600. Obviously this is going to be a negative number when I'm finished. Okay, 105 minus 600 gives me negative 495. Okay, so if I started at 99 and I continued to subtract 6 until I got to the 100th term, that 100th term would be negative 495, which makes sense that this is negative because obviously in this case we are subtracting values, we're not adding values, which means the further and further we go, the more and more negative our numbers are going to get. Okay, so for Monday, all I'm looking for you guys to have on Monday is these notes written down and also this example completed. What I want you guys to do here is use this sequence. Let's go, let's try 21, 24, 27, 30, 33, ... So there's your sequence. I want to know what's the explicit formula for this sequence. And then also, what is the 51st term for this sequence? Okay, so we'll start with this on Monday. I'll be checking for, did you write down the notes? And did you try this example problem? And I hope everyone has a wonderful weekend.